No worries.
Yeah, so let's get started. Right, I'm Frederick. I'm a software engineer that usually knows how to deal with computers and works at DFINITY and mainly on internet identity. And so, yeah, I think in the last session, you guys learned about what canisters are. And today we're looking at internet identity, which is exactly one of those canisters. So if we see on the right here, a representation of the stack of the IC, you see that internet identity is one of those WASM modules at the very top. And so what does it do? Well, internet identity is an identity provider, and as such, it authenticates users as a service for other dApps. But it's a little bit of a special identity provider because it gives you self-sovereign identities that only you as a user have access to. And then internet identity as a system is controlled by the NNS DAO, which is the governance system of the IC as a whole. And the internet identity as an application is 100% on-chain. Even the front-end assets, as you probably have learned in the last session, can be served from a canister. And this is exactly one of the applications of that technology here. It's hosted on a system subnet, which is a little bit of a technicality, but this means that it's essentially provided as a platform service. So the IC as a whole, as a system, pays for that because the system subnet doesn't consume cycles. And we have about 40,000 monthly active users as of this November. In total, there are about a little bit over 2 million identities, but also a lot of those are abandoned and are just bots. And so now we're trying the next technical difficult step, right? Which is switching to slide. Didn't switch, did it?
It didn't, no.
Oh God, this is really terrible. So you didn't even see my previous slide because I was on a...
We've just seen the first slide where it introduces the it just has the title and the date and your name.
Yeah, I mean, I have to set up now that I see what I'm sharing, but I didn't look. This is better. Okay.
Now we can see a different slide, yeah.
Yes, so this was supposed to be the slide that I was talking about previously. Oh. So going to the next slide, which, yeah, now it works, is that I want to give a demo, which of course is a little bit hard because I have to now again change the screen sharing of internet identity. But if it doesn't work, we'll just skip over that. But if you scan this QR code or go to identity.ic0.app, you will be able to, of course, access internet identity as a product, a website, register an internet identity there, and try everything that I will show you, hopefully now, yourself. And so let me fiddle with the screen sharing again.
There we go.
I just managed. Very sorry for this fiddly screen sharing. I hope I don't waste all the time on that. Right, so if you go to identity.ic0.app, you see like a landing page, not quite this one because I've been here before, but you'll see a landing page and you will be able to create an internet identity, at which point you will enter this flow here. And I just want to quickly demonstrate how easy it is to set up an internet identity. And so what we do is essentially we give you an identity that is tied to a passkey that is a WebAuthn device, essentially. And so if I click Create Passkey here, I have the WebAuthn prompt for my YubiKey. So this is a pin-protected YubiKey, so I have to enter the pin and touch the YubiKey. And this was my authentication or the registration thereof. We have a CAPTCHA to prevent bots as well. So if I solve this and go to the next step, then this was the whole registration. I now have an internet identity and I can very conveniently sign into that by just touching my YubiKey, or I could also use device biometrics like fingerprint reader or Face ID. Unfortunately, this is not supported by Firefox, which I have to use here, but it supports screen sharing. But you can use any device really to sign in with internet identity. And so if I continue, we now have the management page where you see the overview over your identity, and you could also add additional passkeys here. You can have recovery methods, you can manage those, you can rename the things, whatever you need to do, whatever you expect from an identity provider really that does key management, right? And so the only piece of information that Internet Identity, the canister, now stores about my identity is the public key of my YubiKey and a little bit of metadata, namely how to name it. And so now if you're wondering, well, what can I use this identity for? We have this nice showcase here that gives you a long list of applications that have integrated Internet Identity and that I can sign into using my Internet Identity. So for example, I don't know if you've heard about it, but there is the NNS Dapp, which is our governance application. So here it's also a wallet, so I can hold tokens like ICP or CKBTC. I can participate in governance, and of course, to make anything useful in this application, I need to sign in with Internet Identity. I can select the identity that I just registered here, then touch the YubiKey. Well, now I'm getting nagged that I should create a recovery phrase, which is always good to do, but in this instance, because it's a demo, I will skip over this. So if you have your security recovery mechanism set up, of course, this screen wouldn't appear. So with just a touch of my YubiKey or fingerprint reader or Face ID, I'm now signed in. I can hold ICP. I have a full-fledged wallet. I could have, let's make this a little bit bigger. I could have Bitcoin as well in here. I can stake my ICP or all the SNSs that I participated, like the ecosystem DAOs, and I can see all the proposals that have happened. Like for example, canister upgrades of canisters that are owned by the NNS governance. So this is essentially Internet Identity. So it's a single sign-on mechanism for any application that wants to use it, and that is a very well-established authentication mechanism on the IC. So to continue the slides, this worked better than expected this time. Yeah, so I can now quickly give you an overview over the authentication methods that we support. So we have WebAuthn and passkeys that you've just seen, and this is also the preferred authentication method, because passkeys are super secure because they create a private public key pair, and the private key is stored on the hardware security module of whatever device you're using, for example, of your iPhone or Android device or in your MacBook, or you can also use a YubiKey, as I have used now, where the private key is stored in the YubiKey, and you have to authenticate to your hardware in some way to unlock the key, which is usually a fingerprint. It might be a PIN input for the lock screen, whatever that device then supports. And the cool thing about WebAuthn is that it's phishing proof. So the browser, when creating the private public key pair, will store alongside it the information to which website this credential belongs. And this makes it so that you cannot even use the credential on a malicious website that you might end up accidentally. So if somebody sends you a bad link or is malicious, you cannot even give them the credential even if you wanted to, because the technology around it stops you from doing that mistake, which is really cool. And you can also not forget a passkey because there's nothing to remember about it, right? You just need to keep your hardware. And for this reason, we support, of course, multiple passkeys in Internet Identity so that you can build some redundancy and have many devices registered there. And there is also this footnote about the hardware security module, because recently Apple started forcing iCloud synchronization on passkeys, which means that the private key in some instances now actually does leave the hardware security module and is synced across the internet, through the cloud, whatever. And other vendors are also looking into synchronization. Of course, it makes it much harder to lose access to a passkey, but it also changes the security model of WebAuthn in general. And so to address this, for the security conscious users that do not want to have their private key synchronized, on Apple devices, we also now offer a PIN authentication mechanism that uses some non-extractable encrypted private key in your browser in conjunction with a user-provided PIN to authenticate you for internet identity. It's not perfect because it relies on browser storage, and to prevent tracking, Apple will also conveniently delete or remove the browser storage after some time of inactivity. So it's not as reliable because you can also forget the PIN, but at least you're sure this data, your key, will not be synchronized. And then, of course, as a third option, we have the recovery phrase, which is essentially a 24-word BIP39 phrase from which we can derive a private key as well. And it's only for recovery purposes. So if I recover using a recovery phrase, I will automatically end up in the recovery wizard that kind of prompts you to register a new passkey, so that the next time around you don't have to provide the recovery phrase again. And it's also the only domain independent authentication mechanism, which of course is also a risk a little bit because it makes it phishable. So never ever enter your recovery phrase anywhere else than in internet identity. So far, so good. Now I want to quickly highlight the architecture of internet identity. So actually, internet identity is a multi-canister system. So we have in this top row the three components that belong to internet identity, which is the front end that runs in your browser. Then we have the actual internet identity canister and a separate canister, which is the archive that internet identity uses to store all the changes on all the identities, so that you later, if you need to figure out why some key was removed or what happened to your devices, you can look into the archive to see all the changes that happened to your identity. And then it's the front end that interacts with the rest of the world, if you will. So on one hand, you have the user that operates on the front end, and the front end in turn then orchestrates the web authentication to authenticate the user. And then we have also the front end that interacts with the Dapp that you want to sign into. And if you remember back to the demo that I just showed, right, I browsed to the NNS Dapp, pressed sign in, and a new window opened with internet identity. And in this new window, I authenticated with my passkey. The window closed again, and I was signed in. And this protocol we will look at in a little bit more detail a little bit later. But this is essentially the authentication mechanism, like the interface that the II exposes, is through window post messages between browser windows. And then the II front end will handle the API calls to the backend. In order to make atomic upgrades of internet identity so that we can submit a proposal that says upgrade internet identity as a single thing, we actually bundle the front end into the WASM file of the backend canister, so that you have a single file, the internet identity WASM file, that both contains all the backend code, all the front end code, and we can change that code using a single proposal to the NNS governance. Right. Now, we want to look at how the IC in general handles identity in a little bit more detail. So identifiers on the IC are called principals. So everything that you can identify somehow, each entity has an assigned principal. And this is how, as a canister developer, you would also identify whoever sends you canister calls, for example. So canisters have principals, subnets have principals, nodes and node providers have principals, and most notably, also users have principals. And we have, on the IC, we have multiple types of principals. So there is a fixed value anonymous principal, which of course isn't that interesting. Then we have the opaque principal, which is assigned to system entities. Like whatever entity exists that is managed by the system, like canisters or subnets, they have an opaque principle. And then lastly, we have the self-authenticating principles, which are assigned to all entities that can sign messages that hold private keys. And these are the interesting ones to look at in the context of internet identity. So a self-authenticating principle is essentially just the SHA of the public key of a private public key pair concatenated with some marker bytes. And this gives you a principle which we treat as an identity on the IC. And this means that we can attribute signed messages that are signed with the private key to this principle if they send along the public key as well. And so, because we can just check the signature to make sure that it actually was created by this identity that holds the key pair, we call them self-authenticating. And so, if we make if we want to make an authenticated canister call on the IC, or to the IC rather, like in our setup, as we have seen, we have the browser. The browser runs some software package that we call agent, which is a TypeScript library that you can easily pull into your project, into your front end, and it handles all the difficult parts about communicating with the IC. So all the message encoding, how you submit it to the IC, everything is essentially handled by the agent. And so what we need to specify to call a canister on the IC is, of course, we need to specify the target canister where the call should go to, which method we want to call, and then we can, if we want to, or if the method requires it, we can supply some argument. And now, if we want to bring in identity into this method call, we can't just essentially state that the sender should be a particular principle, and then we need to attach proof that indeed the message is coming from that principle. And in the case of self-authenticating principles, we can attach the public key and sign with the corresponding private key, and this gives you then a self-contained unit that you can send to the IC that will be treated as a message from this identity that is the principle belonging to that public key. So how do we bring internet identity into the mix? So internet identity, as I said previously, only stores public keys of the WebAuthn credentials that you register, or the public key matching the private key for your recovery phrase. The internet identity canister does not store any private keys at all. So how does it work then, right? So we can get the public key matching our identity from the internet identity canister, from which we can derive the principle, but we're missing the signature part, right? The red question marks here kind of show you the problem. And so to address this, for internet identity, we introduce ephemeral session private key and session public keys. So the browser will generate, once they want to connect to some application using an identity that is managed by internet identity, they will generate a private public key pair that is only used for this session. And they can use that private key to sign this message, which puts essentially a green signature on this canister call. But of course, now it's absolutely not clear how the blue identity is related to the green signature. Why should the IC accept that, right? If you send it as is, it will of course be rejected. And the missing piece here is that we can introduce delegations. So there is a concept of saying, well, if I sign a public key with a different public key, or with the private key rather, such that the signature is valid with respect to the public key, then I can essentially delegate away the right to make canister calls on my behalf for some period of time. And this is exactly what internet identity does, right? So if you sign in with internet identity, you will get the triple from the lower three things from internet identity. You give it the session public key, it will sign that, and it will give it the matching identity that you should use for the session. And this delegation is only valid for the session. And this kind of nicely removes the need to share any private keys at all. And we have now a private key that is ephemeral, that we can throw away later, that we don't need to synchronize anywhere, to use for this session and to make canister calls. So if we look into this authentication protocol a little bit deeper, we have here a sequence diagram of how this works, right? We have the Dapp front end on the left, we have the Internet Identity front end next to it, then the user and the back end, which is the canister. And so, as you have seen in the demo, the Dapp front end, if you press sign in, it will open an II window or a tab, and then it will wait, essentially, because the Internet Identity front end needs some time to load all the assets, to initialize the JavaScript. And once it's ready, it will send the window post message to the Dapp front end to indicate that it's now ready and loaded to receive additional messages. At that moment, the Dapp will then create this ephemeral private public key pair and send over the public key to Internet Identity in order to have it signed. And so with the delegation. And the II front end will then prompt the WebAuthn authentication, and the user would authorize the session, at which point the II front end will interact with the backend to have the canister create a canister signature on that delegation. And then the II front end will relay that signed delegation back to the Dapp front end, at which point the Dapp will then close the II window and is ready to use the initialized agent with this private key that has a delegation to run the session and to make authenticated calls to any canister they want. So let's look into session isolation then. So applications, as we have seen, they can make authenticated calls, authenticating with II, and then call their Dapp canister. They can also call shared canisters like the ICP ledger or any other shared NNS-controlled infrastructure. But of course, there are many different front ends on the IC or in general. And some of those might be malicious, right? And we want those front ends to be isolated from each other, such that an evil Dapp cannot steal your ICP, cannot interfere with the session state that you have on some other application. So how does II isolate your session? Well, the key that you get, so this blue one that was issued by II in this previous example that we've seen with the authenticated canister calling, is actually different for each app that you connect to. So from the point of view of the backend canister, if you sign into two different applications and they call the same backend, you will appear as an entirely different identity. And this identity is derived in a secure way such that you cannot reverse it back to the initial identity. So these identities are truly unlinkable. You have no way that they're in any way related. And this is, of course, great for privacy, although you really need to be careful in practical applications, because maintaining privacy, once you start, for example, receiving funds, is super hard. Because you need to send your assets or your ICP through some mixer or somehow obfuscate in order to not be able to trace back the funds to some shared identity where they came from, right? So it doesn't solve all your privacy problems, but it will give you a very big head start on the whole issue to kind of, if you don't bring in other mechanisms that make it possible to track the user, you're by default unlinkable across all other applications. One disadvantage about this, there are disadvantages to this too, unfortunately. And one of those is that you need an authenticated channel, right? In order to give every application a different identity, it's super important to know who is asking for your identity. And this is why the Internet Identity Protocol uses an additional window or a browser tab, because then Internet Identity can look at the origin of the window post message sender, which, for example, wouldn't work in the case of redirects, where you don't have this information of who made you go to a particular website, or you don't have it in all cases. And the second problem that we have is that the isolation is really absolute. So there are many cases where it's actually nice if you can relax your session isolation a little bit. So if you want to share, for example, information across services because you kind of want to compose services that both services you need to sign into, and then you want to have them collaborate for some purpose, then this is super difficult as it is now. And of course, this is in particular important if you want to use the same assets in many dApps, right? So if you have the ICP ledger canister, whenever you sign into a different front end, you will have a different identity with respect to the ledger canister, which will give you a different ICP address, which will give you a different ICP balance. And this is actually not so convenient for your payment needs, where you would ideally have a few accounts, but not one per application, but like a few accounts that you can pay from and use the same balance. But if we want to relax this session isolation, we need guardrails. And we need these guardrails for security in order to prevent malicious actions across isolation boundaries. And we also need it for privacy, because we want to be really explicit about when and what information is being shared. And so this is the segue into the not yet released upcoming features that we're currently working on. And both of those are related to this session isolation relaxation. And the first one that I'm going to talk about is attribute sharing. So in attribute sharing, or this feature is about kind of exchanging information between applications in a very controlled way, and as an action that requires approval. And this data that could be exchanged are various verifiable credentials. They're usually used in a proof of humanity, or you could have it for some employment credential or legal information. Maybe you need to prove that you are over 18 years old, or you want to prove ownership of something to have like access to a gated community that is only there for all the people that have some cool NFT or whatever, right? And we on the IC, or like we working on internet identity or other, we don't want to become issuers of verifiable credentials, but rather we want to help you share these verifiable credentials across these service boundaries, these isolation boundaries, while maintaining internet identity's unique unlinkability property. So if we look at this example here of a credential that you might want to share, then you have the fact, for example, that somebody is an adult person, and you could prove that by essentially showing your ID, like you do in the real world, right? But of course, there are many things on this idea that are not really relevant to the cause. Only like the date of birth is relevant in the context of age. So we would probably want to hide part of the identity or of the ID, right? And we could actually hide more and more pieces of it until we have nothing more to show, but rather what we would want to share is just the fact that this user is an adult person and not the ID at all, right? And so this user is where internet identity comes into play again, and helps you kind of stating the fact that this user is relevant in both services contexts. And how this works is that if we look at this high overview of a user interacting with II and two applications, namely Dapp A and Dapp B, we see that, as I have explained, right, you have a totally different identity with regards to application A and application B. And to make it a little bit easier to talk about the roles that these applications will have with respect to attribute sharing, we call the green application an issuer, somebody that issues a verifiable credential. And we have the red party, the relying party that wants to consume that data, that wants to receive the verifiable credential. And how this works is that internet identity will generate a new identity, an ephemeral identifier that is only created for the sole purpose of exchanging this piece of information. And so in order to make sure to the issuer and to the relying party that this new identity is actually related to somebody that they knew, Internet Identity in turn will issue verifiable credentials that prove that to the issuer that the identity the issuer knows the user as is the same as the alias. And on the other hand, to the relying party, it will prove that the relying party identity is actually the same as this new ephemeral alias identity. So how does this look to the user? Well, if we have some Dapp on the IC, for example, OpenChat, and we have some gated community. So OpenChat is a chat application like WhatsApp, and we can have groups in there. And one might expect that there are also gated groups. For example, you need to be an employee of the DFINITY Foundation to join, right? So for a user, they will be signed in on OpenChat, and they would want to join that group. Then an Internet Identity tab will open and essentially ask them to approve sharing this particular piece of information with OpenChat. And then if they approve that and authorize it using their passkey, OpenChat will receive a credential that proves that you are an employee of the DFINITY Foundation that is issued to the ID alias. So on itself, it's actually useless to OpenChat because OpenChat doesn't know any user with the principle of ID alias. But we also give OpenChat the additional verifiable credential that relates this ID alias to the relying party. And if we look at what OpenChat has learned now, well, it has learned that we are an employee of the DFINITY Foundation, but it didn't learn how we're known to the DFINITY Foundation, what our principle is there, what is. So we essentially remain unlinkable and didn't share the principle that we have with respect to the issuer. So this is one feature. And the other feature is more tailored to the transaction approval flow, as you probably know it from other chains, where you have to sign explicitly each call that is made to the internet computer or to the chain, each transaction, right? So far, Internet Identity doesn't support transaction approval at all, but it's really useful if you want to use the same identity across these isolation boundaries across many applications. And for example, one case where it would be useful is if you want to talk to the ICP ledger and kind of make transfers, make payments, right? So you have under some identity an ICP balance on the ledger. And if you sign into another application, as I've said, you have a different identity and thus a different balance. And it's super inconvenient because you always need to kind of bring your money first into the appropriate context before you can use it in some application. And so what we propose here is that we introduce some signer component that acts as a proxy to make canister calls or transactions on the IC with explicit user approval. So the signer component, which could, for example, be Internet Identity, now can make canister calls on behalf of this shared orange identity, and both applications can use it. And this is safe because every single call is approved by the user, which kind of complements this session model where you can make authenticated calls non-interactively. So there is just one slight problem with that flow so far, because we want to have this feature work for any canister and for any transaction you could possibly submit to the IC. But also, we don't want to show technical information. So we have a problem that we somehow need to make it clear to the user what they're going to approve. But we also cannot have Internet Identity know every single smart contract that is deployed on the IC and what every canister call and every transactions does, what consequences it will have. So we really have this problem of filling in essentially this action description, this box, so for a user to decide whether or not they want to approve or reject. And ideally, we would fill this box with a message that could be created, or with a mechanism that is compatible with all existing canisters, and it should also work for all possible types of canister calls. There shouldn't be like a list of privileged actions that we know about and the others we don't, or like that we need to kind of implement or kind of make your canister call in a specific way such that we have a message. And on the other hand, with respect to the user, the consent messages should really be understandable to non-technical people. So, because most people don't know what the internals of the internet computers are or how it works, what a canister call is even. But I mean, they do understand sending money, changing ownership, voting on proposals, and it should be in this user language that is easy to understand. And of course, it should also be customizable to users' preferences, for example, the language. So not everybody speaks English. It should be possible to have these approval messages also in German and Japanese and whatever you want, right? You could even have audio files for visually impaired users so that they can listen to what they're approving. And in this interaction that I have shown, the only entity that actually knows for every canister call that we're going to make what the call will do is the target. So we make it the target canister's responsibility to provide us with a consent message. And if the canister does that, we then have a message to nicely fill in here and give a human readable message to the user. And because the IC is so fast, we have like 2 seconds finality, we can have dynamic messages, right? So you don't have like these pre-built transfer some amount of ICP. No, you see exactly how many ICP within a normal readable sentence and where this ICP will go and how it relates to your balance. And you can really tailor the message to each user and each canister call that's going to happen. So if we put all of that together, we have, again, a sequence diagram that shows the flow. So we have the Dapp on the left side that wants to request a canister call from the signer, which then in turn fetches the consent message from the target canister. And once it receives it back, we can build this approval screen. We can display that to the user. And given this is a slide about the happy path, we assume that the user approved this transaction. And if the user does so, we essentially submit the canister call. We get back a certified response, and we can relay that certified response back to the Dapp. And the Dapp can then verify that the canister call was indeed issued as requested from the signer. So these are future features, right? And especially the transaction approval flow that I just showed you is work in progress. So it's building on draft standards that we're working on in the Identity and Wallet Standards Working Group, which is working in a GitHub repository where this QR code leads. And everybody's welcome that's interested in the topic, right? If you're interested in kind of joining the discussion, understanding how identity is handled on the IC a little bit better, you're free to join this working group and participate in the discussions and bring in your opinion as well. So this is really an open forum to discuss any improvements and standards and changes that we should make to the ecosystem. So if you want to join, please do. So this actually brings me to the end of this presentation about internet identity. So the key takeaways really are that we have a 100% on-chain DAO-controlled identity provider that gives you self-sovereign identities with which you can super securely sign into any Dapp with biometrics. It's super easy to use, and it's privacy preserving because internet identity gives you a different identity for every Dapp that you use. And as I've said, we have a lot of cool features also soon to come. And yeah, I'll encourage you to actually start using Internet Identity and join the ecosystem and build something cool with it. Thanks a lot. So now I think we have some time for questions, right?
Yes, you have about 10 more minutes to answer questions. I don't know if you've seen the questions tab on the side.
No, I didn't. Thanks for highlighting this. Target canisters and consent message. Are you talking about metadata for smart contract function calls? Well, yes, essentially it's metadata, but it's rather, I would call it a simulation, if you will, right? So you will send to the target canister everything that you are going to submit as the real canister call as well. So you will say, well, this is the method I want to call, this is the argument. The only thing that you might want to keep hidden is your identity. And then the target canister should produce and you also submit some preferences on how you want to receive the message. And then the target canister should produce a human readable markdown document that you can display as an approval message. Yes. When can we read more on AI? Do you have a GitHub or some articles to share? Yes, actually. So the whole thing is, of course, open source. You can verify the code. You can look through everything. And we also have a specification, of course. And I would need to dig for the links, right? You can find the Internet Identity GitHub on the DFINITY organization GitHub page. Is there a way to share links later with the whole audience? Because I have a few and it would probably be easier to do it that way.
Yes, so what you can do is you can send them to me and I will share them tomorrow alongside the recording of the session. Does that work?
Oh, perfect. Yes, that works.
Yeah.
Perfect.
Cool.
So yeah, there are links. I will send some. In other chains, to interact with Web3, we need a wallet. Can you elaborate maybe with an example? How can a user with identity use a Dapp? Does it really make sense to have an identity to access a Web3 app if you can log in with a wallet? I mean, so the term wallet is a little bit, it's not quite clear what exactly it is because it entails some functionality around asset management, right? But if you look at a wallet strictly in terms of an entity that is able to sign messages, in that case, what Internet Identity gives you over, let's say, a classical wallet, such as, for example, MetaMask that you have as a browser extension, or some application, some native app wallet, what it does is it is a wallet actually, right? So your Internet Identity is able to sign messages, as I have shown through the means of these delegations. And the key is just the kind of the backing private key is the WebAuthn credential, right? And we have what Internet Identity essentially gives you is the key rotation functionality. So a level of indirection. Maybe you have also heard about account abstractions in the Ethereum ecosystem, right? So what you would want to have is have the identity be not tied to the key that you actually use to sign, or have some flexibility in using different keys for the same identity. And this is what Internet Identity does in a very convenient way, right? It gives you passkey access. You can have many devices. And now in the Apple ecosystem, it's even your passkey is automatically synchronized across all devices. And so you don't really have to bother with your kind of private key that is stored in your wallet component, but it's just there using a well-established WebAuthn mechanism. So what does the archive store exactly? Well, essentially, if you think about the identities that Internet Identity keeps, it's essentially a list of public keys that belong to a particular identity with a tiny bit of metadata. And so what it tracks are mostly the changes to this list. As I said, Internet Identity gives you key rotation, so you can add public keys, you can remove public keys, you can mark a public key as a recovery device or as a device used for authentication, and it really just tracks in the archive what you do to your list of public keys. So it's not like if everything works well, it's absolutely not interesting to look at. The only reason you want to have that is to have some auditing trail if you ever kind of think that some changes happened to your identity that you don't approve of or like whatever, right? I mean, you can still lose access to your identity if you, for example, share your recovery phrase with some bad actor or whatever. And essentially, it's the audit trail to make sure to see which device made which changes to the list of public keys when. Right. So going further, the malicious site bad link, does that have to be a passkey associated site already, or is it somehow also for new sites? I'm not sure I understand the question here. So your passkeys, they are associated with the Internet Identity website. So identity IC0.app. This is why, in order to use your passkey, each app that wants to authenticate needs to open the II tab, because only the II website has access to these credentials. This is what I meant with the phishing proofness, right? So, I mean, you're absolutely free to register a passkey with any website that you want to, but it's not the same credential that you would use to access your Internet Identity. So even if you go to some malicious website, you cannot share your credential that you use on Internet Identity with that website. It's gated to Internet Identity. So there is some CLI question that I'll skip over because it doesn't seem related to Internet Identity. What's the difference between other blockchain, seed phrase, and Internet Identity? Well, I mean, for starters, we call it a recovery phrase and not a seed phrase, because a seed phrase is usually used to initialize a wallet with its private key, and this private key will then really represent your identity, right? If you lose that private key, you lose access to your assets. You can no longer make transactions and kind of change your assets. And as I said, Internet Identity gives you the option to have a key rotation, which means you could replace your recovery phrase with a new one. So if you lost your recovery phrase, but you still have a passkey, you can absolutely just say, oh, actually, I want a different one, and generate a new phrase, because the identity is not tied to the key that you use, but you have this indirection of having keys that have access to the identity, and this identity principle that you will get from Internet Identity if you, at that moment of authentication, hold a key that is in the list, but you can change this list. And so the phrase is not tied to the identity, and that's the main difference. So how can I recover my Internet Identity on a different device? So we have multiple options for that. So, I mean, the very crude way to do it is create a recovery phrase and then enter the recovery phrase on the new device. The other way you can do it is you can go to your Internet Identity management page, and you have an option to add passkey. And it will show you a QR code that you can scan with the other device, and then you can link together two different devices that have different passkeys and register a new one that way. And this doesn't then require to enter any seed phrases or copy around whatever. And if you have a laptop that doesn't have a TPM or fingerprint reader or isn't in general capable of using WebAuthn, so you always have the option to buy a hardware dongle, right, a YubiKey, and you can YubiKeys exist there that are compatible with almost any device. This is one way of doing it, but of course this costs money and you might not want to buy such a thing. And in that case, many browsers now offer QR code sign-in with WebAuthn. So if you go to your to Internet Identity and say sign in, you get a list of options. You get prompted by the browser to do passkey authentication. And if you have a sufficiently modern browser, Firefox unfortunately isn't one of those, but Chrome, for example, is, or Safari is as well, you will have the option to display a QR code that you could scan with your phone and then use the TPM of your phone to complete the authentication. Of course, this requires that the phone is already registered with Internet Identity as a passkey. But yeah, so you can absolutely do cross-device authentication. I couldn't complete the challenge. This seems to be related to the course. Maybe I'm looking too ahead. Do we have any coding pointers in live sessions at all, or more like challenge exercise on our own? I think this is also related to the course, right?
Yes, and I think I addressed this whilst you were playing around with the screen sharing. This was right in the beginning, so this should already be answered by me.
Perfect.
So there's a question. I don't know if you've addressed it already, but in the general chat, Ryan is asking if a static ICP site is the best path to start.
A static ICP, what does he mean with a static ICP? But I see there is a new question, right, on the questions tab as well. So it was shown a II's approve pop-up on which looks like a wallet pop-up. Does it mean that II will be a wallet? Well, as I said, it depends on what your definition of a wallet is, right? Internet Identity, or it is planned that Internet Identity will become a wallet in the sense that you hold assets with your identity directly and you approve transactions using that identity. But we want to keep Internet Identity like a small, lean, secure product, right? The less features you have, the less problems you get with it in terms of attack surface or vulnerabilities. So what we won't do in Internet Identity is actually give you a portfolio view of all your assets and the overview of overall your tokens and NFTs and things that you are holding, right? So it will never become an asset management application, but it absolutely will become a component that signs messages, signs transactions. If you're using some other passkey instead of seed phrase, aren't we compromising the security to quite a degree? Because the seed phrase is unbreakable, but I was some pass. So I think you're referring to, so we need to differentiate between passkeys and passphrases, right? So the private key credential that is created when you create a passkey is absolutely as strong as the thing that you get from a seed phrase, right? So cryptographically, what you have with a passkey is also is the same thing that you could derive from a seed phrase as well, which is the private key. But the mechanism of storing your private key is different, right? You don't need to write it down as 20 or 12 or whatever many words, but rather it's the hardware security module that keeps the private key safe for you. And then I showed during the authentication method overview this workaround where you can use a PIN as an authentication mechanism, but the PIN isn't used as on its own, right? What we do instead is we generate the full-blown private key as a WebAuthn device would as well, and then encrypt it with your PIN. So if you hand over just the PIN to some malicious actor, they wouldn't be able to do anything with that. But rather, you really need the browser state as well. And the only reason why we preferred or recommend using passkeys instead of the PIN authentication is because the browser state isn't a very safe place to keep things in terms of reliability of storage, right? So the browser storage can get removed in many different ways, right? You have the periodic cleanup, or if like just the browser state gets too big, or you switch to a new browser, you get the new browser state. Or like as I said, Apple has this anti-tracking feature that wipes browser storage periodically after some inactivity. And essentially, it's not about the credential being stolen, the private key being stolen, but rather it being lost because browser storage isn't a place where you store things that you need forever. How is the developer identity generated? I mean, it depends what your developer identity is. If you're talking about DFX, which is the software component that we ship to develop canisters, this is entirely unrelated to internet identity and is some CLI tooling that we have. And given I'm not a developer on that tooling, I'm not actually sure how that identity is generated. But it's essentially this CLI tool will generate a private key pair, private public key pair as well, and encrypts it with a password, I think. But this is not related to internet identity at all. Let's look back into the chat. Front-end canister. I mean, yeah, there is a tutorial on how to build a static website. I will also share this link with Clara, who then shares it with you, of course, on the tutorial on how to build a static website on the IC. And that's super easy. We have this pre-made canister that you can deploy on the IC and upload assets to it, and everybody can access it. And you have this very simple way of deploying a static website. Yes, I think this is a good way to start. And then you can actually add, like you can have the static website be a single page application, right? You can make it dynamic with some JavaScript. And as soon as you have that, you can actually pull in the software package to authenticate with internet identity, and boom, you have even authenticated users, right? And you can do whatever you want and maintain state on the IC, make transactions, super easy. And we also have a tutorial for that. And I will, of course, share the links as well.
Cool. I think that might be it. I see that someone is typing now, so I don't know whether that is going to be another question or not. But yeah, so just make sure you send over the links to me whenever you're ready. And everyone, guys, I'll share them tomorrow alongside the recording of this session. So, yeah, check out the weekly challenge if you haven't already. Join the Discord server, both the Encode Club one and the ICP Developer Community Discord. Thank you, Federik, so much for joining, for answering all the questions, for giving a great session. It seems like everyone enjoyed it very, very much.
Yeah, thanks for having me. I really enjoyed it as well. And I apologize again for the mess with screen sharing, but thankfully
it's absolutely no problem. You know, we've had way worse than that, so I wouldn't worry about it.
Okay, great.
Great.
Cool.
Okay. See you all, everyone, on Thursday for another session, same time. You should all have the calendar invites, but as usual, I'll kind of remind you guys and I'll post it on Discord as well. But next session will be about HTTP outcalls, so it'll be a great one as well. And yeah, thank you, everyone. Bye.
Thanks. Bye.